Welcome to the fourth video of the physics lecture series for the National Science and Mathematics Olympiad. In this video, we will discuss mass, volume, and density. Let's start with mass. Mass gives us the amount of matter in the body. If you have a stone and a feather, the stone will have a higher mass. The feather might be larger in size, but it doesn't matter. The stone just has more stuff packed into it. Mass and size are different things. Huge objects can have small mass and tiny objects can have large mass. There are also other definitions for what mass is. These are conceptually different, but physically they are all the same. So it doesn't matter which definition we go with, we will have the same mass for the same object. Mass can be defined as the measure of a body's inertia, which is just the resistance to change of velocity when a force is applied. Mass also determines the strength of a body's gravitational attraction to other bodies. It is important to know that mass is not the same as weight. Mass is an internal property of the body. I will have the same mass even if I go to the moon. But my weight will change dramatically. Due to the lower gravity on the moon, my mass would be around 1/6 of what it is now on the Earth. In different countries and in different contexts, we use a lot of different units to measure mass, but its SI base unit is the kilogram. Now, let's move on to volume. Volume is the space something takes up. Take a look at this picture. On figure A, the two containers have the same amount of water in them. Figure B shows that we pour the liquid into a different container with a different shape. Figure C shows that now the level of water is different from originally, but this change of shape doesn't matter. The volume of the water is still the same. So, volume measures how much space something occupies regardless of its shape. It is important to know that two objects can have the same volume but different mass. For example, if we form two identical cubes, one from plastic and one from iron, then the iron cube will have a larger mass. Volume is measured in cubic meters, or if we talk about fluids, we usually express the volume in liters. 1 liter is equal to 1 cubic decimeter. Our third important quantity is density, which tells us how much mass is packed into a given volume. Take a look at these two cubes. In the left cube, the particles are further apart, which means that it has a lower density than the other one. In the right cube, the particles are much closer, so it has a higher density. We can also think about density as how heavy something is for its size. After talking about them conceptually, it is time to get to know the equation connecting our three quantities. The equation is ρ equals m over v. Here, the Greek letter ρ denotes the density, m denotes the mass, and the capital V denotes the volume. Density is a property that is characteristic of each material, but it can change as a function of temperature and pressure. The table on the right shows the densities of some common substances at a temperature of 0 degrees Celsius and under normal atmospheric pressure. You can see that there are orders of magnitude differences between the densities of gases, liquids, and solids. Gases, such as hydrogen or air, have very low densities. Liquids, such as water, have higher densities, and solids, such as iron, have even larger densities. Now, let's see this formula in action. Let's solve the following problem. What is the mass of a solid iron cube with a side length of 2 cm? The density of iron is 7,860 kilograms per cubic meters. So, we know that the volume of a cube is equal to the side length cubed. So, 2 cm cubed, which is 8 cubic centimeter, and then we can just transform that to cubic meters to get 8 times 10 to the minus 6 cubic meters. Now, we know that the formula is ρ equals m over v. If we rearrange the formula, we can get that m equals ρ times v. So, in order to get the mass, we simply have to multiply the density with the volume. So, the mass will be the density, which is 7,860 kilograms over cubic meter, multiplied by the volume, which is 8 times 10 to the minus 6 cubic meters as we calculated it previously. Multiplying these two numbers, we get the final mass, which is 0.063 kilograms. Finally, as a quick recap, here are the concepts of mass, volume, and density again. Mass tells you how much matter is in the object. Volume tells you how much space the object occupies. And density tells you the ratio of the two, so mass over volume, or how much mass is there in a unit of volume. Thank you for your attention and see you in the next video.